All right, we are in the last lesson of Unit 7, Lesson 18. Okay, so work with your partner to solve the following problems. This is what you hopefully have found. So, in one case, we have a party. Elena is buying cups and plates for her party. Cups are sold in packs of 8, and plates are sold in packs of 6. But she wants to have the same number of plates and cups, right? So if she just buys one pack of each, well, that's not the same number, right? So she's going to have to move up. She's going to maybe try to buy 2 packs or maybe 3 packs, and we have the same number. So what we're doing is, if it's going to be, say 2 packs, she's going to look at, then to find out how much she's going to have, she's going to do 2 times how many ever in the pack. So 2 times 8 for packs, that's 16, and 2 times 6, that's 12. Oops, that's still not the same amount. So at this point, hopefully you can catch on and see that we are actually going to be finding the least common multiple. Uh, that would be, or we're looking for common multiples anyway. We're not necessarily looking for the least common multiple, but we're looking for common multiples. So the idea is, what's a common multiple of 8 and 6? What's some number that we can get if we multiply 8 times something and 6 times something? Well, so we want to it says find a number of plates and cups that meets your requirement. So that means it's a common multiple. And so if you think about 8 times 3, that gives us 24. And 6 times 4, that gives us 24 as well, right? So if she bought 24 of each, she could do that. She could just buy three packs of the cups and 4 packs of the plates, and that would give her 24 for each. Now, how many packs of each supply will she need to get that number? So if we say that she is going to get 24 of each, okay, 24 of each. How would she get to 24 with the cups? So this is just kind of what I've mentioned. Is she's going to need 3 packs of cups. And how many would she need to get to 24 for the plates? It would need to be 4, right? So 4 packs of plates. So if she's going to the store, they would say, okay, this is what you're going to pick up. You're going to pick up 3 of the cups and 4 of the plates. Just one smaller. There we go. Okay. So, letter C, name 2 other quantities of plates and cups she could get to meet her requirement. So again, her requirement is the same number of each. So that means we're looking for common multiples of 8 and 6. So one way you can get a common multiple of 8 and 6 is just to do 8 times 6, which is 48. And that way, she can get, if she gets 48, that would involve getting 6 packs of cups and 8 packs of plates. And then another one that you might have missed is 72. So you can get 9 packs of cups, 9 times 8 is 72, and then 12 packs of plates. 12 times 6 is 72. Okay, so for the tiles, a restaurant owner is replacing the restaurant's bathroom floor with square tiles. The tiles will be laid side by side to cover the entire bathroom with no gaps, and none of the tiles can be cut. They've just got to fit perfectly in there. The floor is a rectangle that measures 24 feet by 18 feet. So what is the largest possible tile she could use? Well, this should remind you of a problem we did previously. We know that the tiles are going to be filling up these dimensions, 24 feet by 18 feet. And since we know that they have to have no gaps, no overlaps, they've got to fit perfectly, that means we've got to be able to divide 24 by some number evenly. Okay, but we also have to divide 18 by some number evenly. Okay, so we need to have a number, a common factor that can divide both 24 and 18. And because they want the largest possible tile size, that means we want the largest common factor, or the greatest common factor. So the greatest common factor of 24 and 18, you could list all of the factors of 24 and all of the factors of 18. So factors of 18, we have 1 and 18. We have 2 and 9. And we also have 3 and 6. And that's it. So when we look at these factors, what I'm going to do, you notice I'm just going to list the factors for the smallest number. And then I'm going to see which of these are also factors of 18. So since we want the greatest, I'll start with the biggest and see if that works. Is 18 a factor of 24? No. Is 9 a factor of 24? No. Is 6 a factor of 24? Yes. So 6 has to be the greatest common factor. So the side length has to be 6 feet. And so you could, so 6 feet works because 6 is the greatest common factor of the length and width of the dimensions of the floor. How many of these largest size tiles are needed? Well, we're going to need, for this part, to get to 24 feet, we're going to need 4, right? We're going to need 6 times 4, so 4. And then for this one, we're going to need 6 times 3, which is 18. So we're going to need 4 times 3 tiles to give us 12 total. Imagine finding the area, the length times the width, or the base times the height. If we call this, let's call this the height. If you're going upwards, and each of your tiles is 6 feet, you're going to need 4 of them. So there's going to be 4 going up and 3 going sideways. So just like in the area, you do 3 times 4, and that's where 12 comes from. That's how many tiles are going to be fitting on there. Okay, and then name more tile sizes that are whole number of feet that you could use to cover the bathroom floor. So I guess in this case it would be sizes that are not the largest size, but they're sizes that would still work. So that means that they would be factors still of both 24 and 18. They would need to be common factors of 24 and 18. And, well, we always know that 1 is a common factor of everything. So they could have been 1 foot by 1 foot. That's an easy one. But other factors of 24 and 18, 2 is a factor of both of them. Remember, they're both even numbers, so 2 is a factor. And also 3. So they could have been 1, 2, or 3 feet as well. But since we wanted the largest size, that's why we chose 6 feet before. All right, number 3. Stickers. To celebrate the first day of spring, Lynn is putting stickers on some of the 100 lockers along one side of her middle school's hallway. She puts a skateboard sticker on every 4th locker, starting with locker 4, and a kite sticker on every 5th locker, starting with locker 5. Name 3 lockers that will get both stickers. Well, if you remember from a previous activity, for you to get both prizes as before, or in this case both stickers, you would need to be a multiple of both of these here. So a multiple of 4, because it's every 4th locker for skateboard sticker, and a multiple of 5, since that's where the kite stickers go. So multiples of 4 and 5. So if you were to list the multiples of 5, let's list the multiples of 5. So you have 5, 10, 15, 20, 25, 30, 35, 40, and so on. And you can keep going and going and going here. We want to know which of these are multiples of both of them, right? So they have to be multiples of both of them. So what you're going to notice is that 20 is a multiple of both of them. 40 is a multiple of both of them. So basically what's going to happen is you're going to be going by 20s in order to be the multiples of all of them. So instead of listing every single multiple, if you catch on, you know that 20 is going to be a multiple. 40 is going to be a multiple that's going to get both of them, right? That's going to be a common multiple. 60, 80, and 100. Those are going to get 2 stickers each, as both of those are multiples rather of 4 and 5. So for B, after Lynn makes her way down the hall, will the 30th locker have no stickers, 1 sticker, or 2 stickers? Okay, well, the 30th locker, what is it a multiple of? Is it a multiple of 4? No, so it's not going to get that sticker. Is it a multiple of 5? Yes, so it will get the kite sticker. It will get 1 sticker because 30 is a multiple of 5, but not of 4. For number 4, the school nurse is assembling first aid kits for the teachers. She has 75 bandages and 90 throat lozenges. All the kits must have the same number of each supply, and all supplies must be used, so nothing left over. What is the largest number of kits the nurse can make? Well, hopefully now you can see we are looking for the greatest common factor. We're looking for a common factor, and if it's the largest number of kits, it's the greatest common factor that we want. It's the greatest common factor of 75 and 90. If you remember from a previous activity, we listed the multiples of 15 up to 100, and 90 was one of them. So 15 is a factor of 90, and 15 is also a factor of 75. So if you listed all the factors for 75 and all the factors for 90, 15 would be the greatest common factor. So we can say she would make 15. How many bandages and lozenges will be in each kit? Well, what that means is that if you're going to have 15 kits, how many bandages are going to be each kit for 75 total? So it's 15 times what is 75. Okay, so it's 15 times 5 is 75. So it's 5 bandages. And how many would be 15 times what is 90? It's 15 times 6. So 6 lozenges. Okay, 15 times 5 is 75. 15 times 6 is 90. All right, so what kind of mathematical work was involved in each of the previous problems? So what we can do, we can just put a check mark or an X in the problems that involved the various practices. So for the party, did we find multiples in the party? Remember, it was 24, and 24 is a multiple of 8 and 6, so yes, we did. So we can go ahead and we can let's put a little check mark. Okay. Get some color in here. So it was used multiples. Did we find the least common multiple? Yes, 24 was the least common multiple, so it was that. Did we work with factors? No, factors weren't important. We were doing the multiples here, so we weren't finding the greatest common factor either. For the tiles, what did we use? Tiles, we listed the factors. Right? And remember, 6 feet was the greatest common factor because we listed the factors of 18, and we said, okay, which one is the biggest that is also a factor of 24? So we found the greatest common factor. So it wasn't multiples, we found factors, and we found the greatest common factor. All right, for the stickers. Stickers here, remember it was every 4th locker and every 5th locker, so we had to count by 4s and 5s, which is just another way of saying we were finding the multiples. And so we found the multiples. And when you look at it here, so let's go ahead and check off. We use multiples. Okay, did we find the least common multiple? Well, we did because the first locker that was going to get both was 20. And so that's the least common multiple. That's the first one that gets both is the least common multiple. So we did find the least common multiple there, even though they didn't specify it. And then for the kits, what did we do in the kits? Well, we found out that we found the greatest common factor, right? So that means we were finding factors, and we found the GCF. If you remember, though, when they asked us how many bandages and lozenges will be in each kit, 5 bandages and 6 lozenges, okay, that's a way of working with the multiples. We know that 15 times 5 is 75, and 15 times 6 is 90, so we actually did find the multiples there as well, but we didn't find the least common multiple. All right.